The James Webb Space Telescope, an astounding piece of equipment built to outperform the Hubble Space Telescope, has made a terrifying and amazing discovery that might completely change our perception of the universe. It has successfully detected a faint glow coming from a staggering 7 trillion miles away. Can this glow be shining city lights coming from some mysterious extraterrestrial world galaxies away from us? Well, let's start from the beginning. A few years ago, NASA's infrared Spitzer Space Telescope helped us spot a family of 7 rocky exoplanets orbiting the same star. This star is known as TRAPPIST-1, and recently, our new infrared powerhouse, the James Webb Telescope, has measured the temperature of one of those distant worlds. It was a planet called TRAPPIST-1b. Unfortunately, it turned out that this Earth-like planet was totally uninhabitable. Astronomers took James Webb's mid-infrared camera, called MIRI, and looked at the planet's thermal emissions. We can picture the whole process as scientists using heat-sensing Terminator vision. The results were quite disappointing. TRAPPIST-1b turned out to be scorching. Its average temperature was around 450 degrees F. That's as hot as in an oven. Plus, the planet most likely doesn't have any atmosphere. At the same time, this discovery was another record-breaking first for the telescope, which had already produced some newsworthy results by that time. It was the first time researchers detected any form of light emitted by a small and relatively cool exoplanet similar to the rocky planets in our own solar system. No previous telescope had enough sensitivity to measure such dim, mid-infrared light. When 7 TRAPPIST-1 exoplanets were first discovered, the astronomical community was ecstatic. That's because all those faraway worlds were about the size of our home planet and located in their star's habitable zone. It's the region that is just the right distance away from a star for liquid water to exist on a planet's surface. Thus, the planetary system became the best place to look for rocky planets with an atmosphere. But don't get too excited yet. These planets aren't likely to become new worlds for humans to explore, mostly because the TRAPPIST-1 planets are totally out of our reach at the moment. They're just too far away, at a whopping 235 trillion miles away. Their star is also much smaller and redder than our Sun. It's classified as an M-dwarf star. In our home Milky Way galaxy, there are twice as many of such stars as there are stars like the Sun. And they're also twice as likely to have rocky planets orbiting. It's probably not surprising that astronomers are very interested in such stars. They're the main targets for seeking potentially habitable planets. And it's also way easier and more convenient to observe rocky planets around such smaller stars. But there's a catch. M-dwarfs are more active than our Sun. They frequently flare and spew high-energy rays which are likely to be extremely damaging to planets' atmospheres and any forms of extraterrestrial life. When researchers examined TRAPPIST-1b before, their observations weren't sensitive enough to determine whether this world had an atmosphere, or if it was just a barren rock. But now, we know. The planet is tidally locked to its star, which means that one of its sides always faces the star, while the other is stuck in perpetual darkness. The latest simulations suggest that if this planet had an atmosphere, its temperatures would be much lower since the air would redistribute the heat around both sides of the planet. Unfortunately, the James Webb Telescope recorded much hotter temperatures than needed for such a favorable scenario. It indicates the absence of an atmosphere and knocks the planet off our list of possibly habitable worlds. But the main excitement here isn't actually the features of TRAPPIST-1b. The main takeaway is that James Webb is capable of making such kinds of measurements. It'll help us explore the atmospheres and temperatures of many other distant worlds.
Wow, the NASA hotline is ringing off the hook. The call center operator is all sweaty from stress. They barely have time to answer the phone, and all the messages they get say the same thing. There's something glowing on the moon. Indeed, hundreds and thousands of amateur astronomers were watching the moon that night, and suddenly there was a bright light on it, as if someone had lit a powerful spotlight on the surface. Scientists immediately began to look for an explanation to this phenomenon. They first thought it was simply the glow of an airplane flying between the observers and the moon, but then it wouldn't have been seen by so many people from different parts of the world at the same time. The next suspects were the Starlink satellites. Theoretically, one of them could have played a cruel trick on amateur astronomers. They could have mistaken the small satellite's light for a flash of light on the moon. But then again, if the satellite were the culprit of this mess, The flare wouldn't be static, but moving. While some scientists continue to search for an answer to this mystery, others decide to investigate the phenomenon in more detail. For this purpose, they have built a new telescope north of Seville, Spain. The conditions there are quite suitable for observing the moon. The telescope has 2 cameras, controlled remotely from the campus in Germany. If both cameras pick up any unusual phenomenon on the surface of the moon, it will quickly zoom the telescope there to see what's going on. It'll also require advanced artificial intelligence to teach the cameras to distinguish between the unexplained phenomenon on the moon and the light of an airplane, a satellite, or a small meteorite that just entered the Earth's atmosphere. While the telescope is doing its investigation, we already have a theory that may explain the appearance of such bright round flashes on the moon's surface. So, the moon influences the tides of the seas and oceans on Earth with its gravitational force. But the Earth can't affect the moon in the same way. Only the force will be 32.5 times stronger. While the moon orbits the Earth, at one point, it may be as close to our planet as possible. Then the force of the interaction will be greatest. At this point, tidal forces may force cracks in the surface of the moon to open and release gas from its interior. A powerful jet of gas will lift the lunar dust with it, and what we see as a bright flash through our telescopes is really just a fog of dust, which is round and reflects sunlight well. If you look at it from a distance, it really does look like a flash. As the dust rises, we think there's been a small explosion, and that flash gradually fades as the dust settles down. These things happen all the time on the moon's surface. They're called transient lunar phenomena, and besides lunar flashes, much more mystical and bizarre things have happened. Back in 1178, 5 monks claimed to have seen the moon, being in the shape of a horn, begin to split in 2 from an upper point. Then fire and sparks began to blaze from the place of separation. It was as if a dragon were spewing flames. In the next moment, the moon began to pulsate and then returned to its calm state. This phenomenon was repeated more than 10 times, and the flames took different shapes each time. When this nightmare was over, the moon turned black. It wasn't until the 20th century that scientists tried to explain the phenomenon. They theorized that a large asteroid collided with the moon at the time, and it was this asteroid that should be blamed for creating the Giordano Bruno crater, 15 Brooklyn bridges wide. But in that case, millions of tons of fragments from the asteroid would have hit the Earth as well, and then people would have seen an incredible meteor shower. It would have been very bright, and the memories of it would definitely have been in the archives. But that didn't happen. Now the phenomenon the monks observed seems questionable. Perhaps they did see an asteroid fall, only it was falling on the Earth itself, and they perceived the light from the burning meteorite as something sinister happening on the moon. Or maybe the monks were simply imagining things. There's no witnesses to this event other than them. Another unusual phenomenon is the blue and red lights on the moon. They can be seen when it's horn-shaped, and this occurs most often in the Aristarchus crater. The flashes come and go very quickly, almost like lightning. In fact, this is electricity. Tidal forces are to blame for this too. They cause mechanical stress to build up in the rocks. This can produce an electric field, which creates the blue flashes that have surprised many amateur astronomers. There can also be starbursts on the moon. We can blame this on meteorites that fall on the surface. Because the moon has no atmosphere, asteroids that approach it don't burn up. Having a lot of weight and speed, they cause an explosion on impact. And here on Earth, we see it as a starburst. For example, on May 13, 1972, there was a meteorite impact of 1,000 tons of TNT near where Apollo 14 landed. If we lived much earlier, we might have witnessed constant bright flashes on the moon's surface. All the craters there are formed by such meteor strikes. So imagine the fireworks that were there years ago. And a lot of those meteorites were even useful too. They brought water with them. Yes, there is water on the moon. NASA confirmed this fact after studies with the Sophia telescope. It was mounted on an airplane. The observations were made from the upper atmosphere of the Earth. At such an altitude, the dry air allowed the telescope to see even the smallest details. Water might have been in the craters at the poles of the moon. These places have never seen light, and the water there might be encased in ice. But Sophia found water on the sunlit surface of the moon. Of course, it's only H2O molecules that are present in the dust layers, but that's something. If we manage to collect all this water, we'll get very little of it. In comparison, the Sahara Desert has about 100 times more water than we found on the moon. But an even more unusual phenomenon is happening there right now. The moon is actually rusting, just like a piece of old metal. For rust to appear, we need iron, water, and oxygen. Lunar soil has enough iron in it, and as we've already learned, there's some water too. The last piece of the puzzle is oxygen. Everyone knows there's no atmosphere on the moon, and we can't breathe there, but oxygen is still present. The solar wind brought it there. The wind from our warm star moves at an extremely high speed. It scrapes oxygen from the upper parts of our atmosphere and carries it further through space. Eventually, the wind with the oxygen molecules reaches the moon. Voila! All the ingredients for corrosion are in place, and the iron ore on the surface of the moon begins to take on a reddish hue. If this process goes on long enough, in the distant future, the moon will look like Mars. It will turn orange-red. Yes, the signature color of Mars came exactly from that corrosion that began there thousands and thousands of years ago, when there were rivers and seas with water and an atmosphere with oxygen. Other strange objects that can be seen on the moon were left there by humans. Between 1969 and 1972, 12 people visited there as part of the Apollo program. In all, there were 6 landing sites where the astronauts left a bunch of stuff behind. Besides a couple of dozen satellites and spacecraft that fell or landed softly on the moon, there is a lunar rover, some United States flags, a family photo of one of the astronauts, and even 3 golf balls. And the first 2 people to be on the moon left behind a whole pile of stuff. When they were about to go home, they took a lot of soil samples and rocks with them. And to carry it all away, they had to get rid of everything unnecessary on board the lunar module. The TV camera, the sample collection tools, the science equipment, and even the armrests from the seats. The astronauts stood outside the lunar module for a full 8 minutes and threw out a whole mountain of unnecessary items. If you collect all these objects and debris that we left there by 12 astronauts and put them on the scales, it will show about 199 tons. It's like 3 heavy armor tanks or 3 large passenger planes. Strange, but true.
Whether you look up at the night sky or marvel at the picture of the universe online, the question remains the same. Why is space dark? Why isn't it colorful, like Earth's blue daytime sky? The answer is certainly not a lack of light. But first, let's figure out why it's light on our planet and why our sky is so beautifully blue. Unlike in the vacuum of space on Earth, we've got an atmosphere filled with different kinds of gas molecules. Also, since Earth is relatively close to the sun, a lot of light reaches the surface of our planet. When these light waves hit the molecules in Earth's atmosphere, blue and violet ones are just the right length to scatter. As a result, we've got a blue sky. During the day, the sun's light completely covers the side of Earth facing it. Then, the sun sets at the end of the day. And since light waves move in a straight line until they make contact with something, they can't reach very far into the side of Earth that no longer faces the sun. Without the sun, all we have is the darkness of space again. You might object, but the moon is just as close to the sun as our planet. Then why is its sky always black? Unlike Earth, the moon doesn't have a strong atmosphere. And even though the sun's light does reach its surface, there are no gaseous molecules for it to bounce off of. That's why the whole spectrum of visible light makes its way down to the surface of our natural satellite. Okay, but there are billions of stars in our galaxy alone. There are billions of galaxies in the universe. Plus, you can find other space objects that reflect light, like planets or large moons. Then why don't all these light sources make our night sky super bright? This contradiction is known in astronomy and physics circles as Olbers's paradox, and it can be explained by the theory of space-time expansion. This idea claims that the universe expands faster than the speed of light. That's why the light coming from distant galaxies is likely to be stretching and turning into infrared light, as well as microwaves and radio waves. They are not detectable by human eyes. That's why they appear black. Human perception plays its role here too. Our eyes are well adapted to the conditions on our home planet, and how we perceive light is influenced by our visual system. If there are no familiar cues, like an atmosphere or objects reflecting light, it's likely to be difficult for people to perceive light in space. Interestingly, stars do give off light in all colors, including those not visible to the human eye, like infrared or ultraviolet. If we could see microwaves, space would seem glowing to us. That's because the cosmic microwave background, which is energy leftovers from the Big Bang scattered around the early universe, still fills the cosmos. One more reason why interstellar and interplanetary space seems to be dark is that space is an almost complete vacuum. So there's virtually nothing between stars and planets to help light scatter to reach our eyes. And with no light, all our eyes see is black. At the same time, space might not be as black as astronomers initially thought, and as your eyes tell you. At least that's what a 2021 study suggests. With the help of NASA's New Horizons mission to Pluto and the Kuiper Belt, scientists have managed to see space without any light interference from Earth or the Sun. The research team looked through the images taken by the probe and subtracted all light from the Milky Way, known stars, and possible galaxies. They also removed the light that might have leaked in from camera quirks. And guess what? The background light of the universe was still twice as bright as predicted. The reasons for this extra brightness are still unknown. Astronomers will keep studying this topic. But until they find the answer, one thing we should probably agree on: space seems to be more charcoal than pitch black. When a team of astronomers embarked on an ambitious project to craft a comprehensive 3D depiction of our galaxy, they anticipated standard findings. Yet, they stumbled upon something completely unexpected. Dr. Anna Banaka, a distinguished scientist from Harvard, detected an unusual interference in the stellar streams of our galaxy. These stellar streams are essentially pathways of stars that traverse galaxies in unison. The specific stream in focus, named GD1, spans a remarkable distance across our celestial canvas. Historically, this stream maintained a consistent line, molded by the galaxy's gravitational pull. However, Dr. Banaka observed an anomaly, a gap with an irregular outline. It appeared as though a massive entity had recently burst through GD1, its gravitational prowess pulling stars along its path. Intriguingly, telescopes couldn't pinpoint what caused this disruption. The burning question then was, what could this invisible force possibly be? I hope this unknowable force doesn't stop you from clicking the subscribe button, giving it a like, and hitting the bell. Your support is very important. Thank you. There's a hypothesis that an unfamiliar star could be the culprit. However, Dr. Banaka believes that the size of this disturbance is much larger than any known star. It would need to be a staggering 1,000,000 times the mass of our Sun. But let's consider another possibility. What if a gargantuan black hole, akin to the one at our galaxy's core, caused this disruption in the Milky Way? If two such black holes neared each other, they might get trapped in their mutual gravitational pull, leading to a potential catastrophic collision. Then, the stronger of the two holes would consume the weaker one, and one huge supermighty black hole would appear. But people have yet to witness a collision of black holes. Plus, scientists can't predict the consequences of such a merge, even though they've simulated it on powerful computers. The only obvious fact is that it would produce incredible amounts of energy. Huge ripples would travel through the entire universe, bound to hit our planet eventually. Then again, two black holes in one galaxy might refuse to merge. Imagine this. A supermassive black hole hundreds of millions of times the mass of the Sun is spinning in the center of the Milky Way at a phenomenal speed. Another spinning black hole approaches ours. What do you think will happen? Right. One of the holes, most likely the intruder, will get kicked out and sent hurtling away like a frisbee flying through space. And who can guarantee that it wouldn't head toward the Earth? Luckily for us, there aren't any supermassive black holes in the vicinity, so this theory fails to explain the mysterious bullet hole phenomenon. Dr. Bonica still doesn't rule out the possibility that the intruder is some kind of luminous, star-like object. After tearing a hole in the Milky Way, it could be hiding somewhere in the galaxy. But again, it seems highly unlikely because of the object's huge size. I mean, we're talking 30 to 65 light-years across. In any case, predicting the location of this mysterious intruder is as challenging as guessing where your missing sock disappears to after laundry day. Speaking of things disappearing, don't let this channel vanish from your feed. Hit that subscribe button. The intruder could have been blazing fast, requiring minimal mass to cause such a disturbance in the stellar stream, or it could have been a slower, massive behemoth. Astronomers are still scratching their heads, which just goes to show that some mysteries are harder to unravel than others. In the vast abyss of the cosmos, amidst the stellar tapestry, lies the Milky Way, not just a river of stars, but our very abode. Envision a gargantuan pinwheel spanning eons, rotating in the void of space, a place born from time's earliest whispers, around 14 billion years ago, a dominion of starlight, nebulae, and cosmic wonders, housing not just celestial bodies but stories, yours, mine, and even that untidy child from down the lane. Picture a canvas so wide, taking 100 millennia for a beam of light to traverse. Within it, our sun, a mere speck, takes 250 million years to complete its cosmic marathon around the galaxy's heart. And when night graces our world, those myriad twinkling eyes above, most are part of the Milky Way's sprawling limbs. This river of starlight was once an enigma to our ancestors, a milky stroke across the heavens, hence the galaxy's poetic name. But hold your breath for a twist in the tale. From the heart of this stellar expanse, a curious signal emanates. Like the dots and dashes of Morse code, there exists a mysterious message, perhaps a celestial whisper. Decades past, we spotted gigantic tendrils hanging ominously close to the enigmatic Sagittarius A*, our galaxy's heart, harboring a monstrous black hole. Recent revelations have unveiled new tendrils, puzzlingly shorter, their orientations odd, reminiscent of spokes radiating from a wheel's hub. Though the tendrils share common traits, their origins are believed to differ. Towering vertical ones pierce the cosmos, while the horizontal siblings evoke Morse code's eloquence, the former magnetic, while the latter exudes thermal warmth. These baffling phenomena, though celestial in scale, may help unveil the secrets of our galaxy's central black hole. Yet, the mysteries don't end there. From the depths came another signal, frequent pulsations, unlike any celestial body we know. Its origin, ambiguous. Some speculated to be remnants of a collapsed star, while others pondered the existence of an entirely unknown celestial object. And as if the galaxy wasn't enigmatic enough, a new conundrum arises. Our gamma-ray telescope unveiled an intense glow from the Milky Way's core. For a decade, this luminescence baffled minds. Is it the cataclysmic destruction of elusive dark matter? Or is it the dance of millisecond pulsars, neutron stars spinning at unimaginable speeds? Debates rage, with the pulsars being prime suspects, yet skepticism abounds. Some postulate it could be due to cosmic interactions, while others question the peculiar spherical congregation of these pulsars. The galaxy, with all its grandeur, remains a labyrinth of riddles. All we can do is persist in our quest, diving deeper into the enigma that is our celestial home. Within this vast cosmic theater, every revelation begets more questions, and every answer we unearth draws us further into an intricate dance of wonder and uncertainty. Each star, each pulsar, every tendril is not just a point of light or a phenomenon, but a chapter in the grand tale of our universe. We, as humble residents of this Milky Way, are constantly driven by an insatiable curiosity. With every tool we forge and every telescope we peer through, we seek to understand our place in the vastness, to decipher the messages encoded in the fabric of space and time. These mysteries, from the Morse code light tendrils to the inexplicable gamma rays, are beckoning calls for humanity. They whisper to us of stories yet to be told, of puzzles waiting to be solved, and of our ever-evolving understanding of the cosmos. In the face of these revelations, we are reminded of how much there is still to learn. And yet, with every discovery, we inch closer to understanding the intricate ballet of the universe.
Larger than Earth, it is in the habitable zone of the star. It's the perfect distance, not too far away and not too close. So the temperature isn't too high or low there either. Water, if it exists on that planet, can be in a liquid state. And so, life can survive and evolve there. Maybe it's developed enough to send us the signal that we had received. A radio signal is basically waves. They have a certain frequency and length, and we can always tell an artificial signal from a naturally generated one. The signal that we picked up from Proxima Centauri b had a frequency of 982 megahertz. The regular radio we listen to in the kitchen or in the car picks up signals around 100 megahertz. That's why scientists have concluded that the signal was created artificially. Such signals could have a way of communication between the developed worlds. If this is really a message from an outer space civilian, we should be able to decode it. For this, any civilization must use the simplest method of encryption. For example, Earth has already sent a radio signal into space. It was the Arecibo message. This message consists of 1,679 digits. It's a rectangle of 23 by 73 squares that has information about our civilization encoded using a binary code. At the top of the rectangle, there's a system of numbers that we use. They're marked in white. This purple thing is the key to read the next part of the message. The atomic numbers of the elements like hydrogen, carbon, nitrogen, oxygen, and phosphorus are encoded in this key. These are the key elements that can start life. If those who receive this signal can make sense of the numbers in the key, they can read the next part of the message. These green things are the building blocks of our DNA chain. And right at the bottom here is the DNA chain itself. The white rectangle indicates the number of pairs of these building blocks, and the blue spirals show the shape of a DNA chain. And then we see the human silhouette itself. The white and blue object to its left is a coded number of our average height. The human itself is drawn here at the ends of the DNA strand, so that the outer space civilization can understand what we look like. And the white rectangle to the right of the human sketch is the number of Earth's population at the time of the message. That's 4.2 billion as of 1974, almost half the number we have now. The next part is a drawing of our solar system. The big yellow square is the sun. Then come all the planets in our solar system, including Pluto. Earth is shifted up a bit here, so that outer space civilization can understand where this message is coming from. And the last drawing is the observatory from which this message had been sent into space. This signal is now on its way to the M13 star cluster 25,000 light years away from Earth. So it won't get there for another 25,000 years. And we'll need another 25 to get a response if there is really someone on the other side who can receive the signal. If the signal from
Weird, unusual sounds out of nowhere are spreading all over our galaxy, constantly repeating, and it's something we've never heard before. Scientists discovered it in 2020, and it was nothing like any of the other energy signatures they ever studied. Powerful and bright radio signals occurring from time to time, mysteriously disappearing within a day. It doesn't fit the profile of any space body we know. The signal is a bit irritating, and it disappears without a schedule. When scientists tried to match the signal with some other telescopes, it was gone. But not here, since they mostly have X-ray counterparts. Very dense collapsed stars, like pulsars and magnetars, are also not a choice. The closest solution they got is a mysterious class of objects we know at the Galactic Center Radio Source, GCRT. It's a radio source that brightens and rapidly glows. It decays near the center of our galaxy and could help us unravel the mysteries of the universe. If you had a flying car that could go up at a speed of 60 miles per hour, you'd only need 1 hour to get into space. The moon is a little bit farther, 250,000 miles, which is about 10 times the circumference of our planet. That means a moon trip would be like taking a tour around the globe and doing it 10 times straight, which would take less than 6 months. A trip to Pluto would take over 800 years. Proxima b is the closest Earth-like neighbor we have. It's a small rocky world that orbits the closest stellar neighbor of our Sun. It orbits the star's habitable zone, an area that's far enough from any star to have moderate conditions, not too cold and not too hot for liquid water to at least hypothetically exist. If you tried to travel to Proxima b at a speed of 25,000 miles per hour, which is the speed of the Apollo moon rockets, it would take you over 112,000 years to get there. You might not be able to breathe there. No one knows if Proxima b has an atmosphere. Humans explore the universe all the time, but we can only see around 5% of the matter up there. And Albert Einstein was the first one that realized the empty space is not really nothing. The rest we can't see is actually made up of invisible matter, also known as dark matter. It's about 27%, combined with something called dark energy, which is 68%. If you try to pour water into space, of course outside of a spacecraft, it would immediately boil away or vaporize. That's because there's no air or air pressure in space. As air pressure lowers, the temperature you'd usually need to boil water at also gets lower. Keeping that in mind, water boils way faster on a mountaintop than, for example, at sea level. There's no air pressure in space, so water could boil at a very low temperature. Scientists believe that there are at least a couple of billion galaxies out there. We don't know the real number, and probably never will, but they tried to calculate it by counting how many galaxies we can see in a pretty small and restricted area of the sky. It may seem as if the universe was filled with stars and a couple of planets here and there, but our home galaxy has at least 100 billion planets. If you fill a balloon with helium and release it, you'll notice it floats very high. It'll go up into the atmosphere, but it won't go into outer space. The higher you go, the thinner the air in our atmosphere gets. Your balloon will rise up until the point where the atmosphere surrounding it has the same weight as the helium inside it. That will happen at approximately a height of 20 miles above the surface. So this is as far as a helium balloon can rise. We don't really know how big the universe is. We can't see its edges, nor do we know if it even has an edge. We use technology to see out to a distance of around 14 billion light years from our planet. This means we can see around 28 billion light years in diameter across, starting with the outermost layer of our atmosphere that ends at around 600 miles above our planet's surface. Although the size of the universe is constantly changing and gets bigger through time. Mercury is closest to the Sun, so most people think it's the hottest planet too. Still, Venus is the hottest planet. It's the second planet away from our central star, around 30 million miles farther from the Sun compared to Mercury. Mercury doesn't have an atmosphere, which is like some sort of a warming blanket that helps maintain the heat coming from the Sun. Venus has an unexpectedly thick atmosphere, around 100 times thicker than the one we have. Its atmosphere doesn't let the heat out, it just keeps it, and constantly makes Venus hotter and hotter. Also, it mostly consists of carbon dioxide that freely lets solar energy in. But it's less transparent to lose long wavelength radiations that the warm heated surface emits. The average temperature there is around 875 degrees Fahrenheit, which is hot enough to melt tin. The maximum temperature on its neighbor, Mercury, is 800 degrees Fahrenheit. In maybe 2 or more billion years, it will be way too hot for life to exist on our precious planet. As the hundreds of millions of years go by, our sun will keep getting hotter and brighter. Eventually, temperatures will be so high, our beautiful oceans will be wiped away. Since they produce 70% of the oxygen we need to survive, there will be no life without them. All of this means that our planet will simply become a vast desert, something like Mars is today. Pluto, a very distant used-to-be planet, now dwarf planet, is actually smaller in diameter than the entire US. The biggest distance there, from Maine to Northern California, is approximately 2,900 miles, while Pluto is only 1,473 miles across. Pluto is very far, but the edge of our solar system is 1,000 times farther away than this dwarf planet. But astronomers found many space objects orbiting our sun way farther than Pluto. such as Kuiper Belt objects and trans-Neptunian objects. There's also an Oort comet cloud that goes half a light year from Pluto, also 1,000 times farther. A neutron star is really heavy. Just a teaspoon filled with it would weigh 6 billion tons. Neutron stars are something that remain from huge stars that have run out of fuel. The fading star explodes, and its core falls apart, but due to gravity, it forms an extremely dense neutron star. These stars typically have a mass of up to 3 suns, but the radius there is around 6 miles, because this is one of the densest things in our universe, at least that we know about. The universe has a color, and it averages to be some kind of beige, or as they call it, cosmic latte. It also has its own smell that reminds you of seared steak or hot metal. At least, that's something astronauts floating in space have said. If you want to build a spacesuit, get ready to work really hard. It takes 5,000 hours to make it and will cost you $1 million. A really good one will have 11 layers of material and weighs about 110 pounds, and it needs to be comfortable. You'll need more space in there because you grow up to 2 inches when in space. When you're floating around in space, Earth's gravity doesn't have any impact on you. That's why the vertebrae in your spine might expand and relax a little bit, which means you'll be maybe 3% taller. For 6 feet, it's about 2 extra inches. Oh, don't worry, it's not permanent. As soon as you go down to Earth, you'll shrink back down to your normal size within a couple of months. Space isn't the best option if you want to have a conversation with your friend, because up there, sound doesn't travel at all. Molecules there are so far apart that sound vibrations can't reach them, which automatically means they can't vibrate, so we can't hear them. Movies are not accurate with this. No one could hear you screaming in space, too. We kind of live inside our sun. The sun is not just that big hot ball of light located 93 million miles away from us. Its outer atmosphere is way bigger. It extends far beyond the surface we can see. Our planet's orbit goes through its tenuous atmosphere. The evidence is when gusts of the solar wind generate the southern and northern lights. That means, in some way, we live inside the sun. Not just us, other planets too, including distant Neptune. The heliosphere, which is what we call the outer solar atmosphere, extends to about 10 billion miles.
Hey, wake up! Quick, listen to that. It's a 5-second FM signal coming from one of Jupiter's moons. You fumble for your phone and inform your colleagues. They freak out over the news and rush to the lab. You've been a scientist working with the Juno probe, exploring Jupiter for years. But this is the first time you've witnessed something so unusual. Ganymede is Jupiter's largest moon and the biggest moon in our solar system. If this space body didn't orbit around Jupiter, it would be classified as a planet. It's even bigger than Mercury and Pluto. What makes this moon stand out among others is the fact that it has its own magnetic field. The moon was born around 4.5 billion years ago. It means it's as old as Jupiter itself. This planet-sized space body takes 7 Earth days to orbit its planet. Everyone gathers at the laboratory, impatiently waiting for you to play the recording of the signal coming from space. Your colleagues get their game on, trying to figure out what the source of this mysterious sound is. Around 40% of Ganymede's surface is dark, with craters scattered around, and 60% is light-colored. There are formations that were probably caused by tectonic activity or the release of water from under the surface. Scientists managed to discover a thin layer of oxygen trapped in the moon's atmosphere. The temperatures there are super low, between -170 to -200 degrees Fahrenheit. There isn't much information about how the moon behaves or what chemical elements it hides inside. Some of your colleagues try to create the same conditions that existed when the sound was transmitted. For hours, they sit there waiting, but nothing. Maybe it was a fluke. You get to the control system and activate the Juno spacecraft. The main point of this mission is to observe Jupiter's gravity, magnetic fields, the atmosphere, and the planet's evolution. By the way, there's also some evidence that Jupiter's largest moon is evolving too. Since it has a magnetic field surrounding it, auroras pop up all the time. Those are glowing gas circling the moon's north and south poles. If life existed in such a place, it would probably be at the bottom of Ganymede's extremely salty ocean. For a long time, scientists thought that the sun was a crucial component to kickstart life. But now we know that there are organisms dwelling deep at the bottom of the oceans. Those are doing just fine without sunlight. The oceans of our planet are teeming with some of the most bizarre creatures of all shapes and sizes. Sea lilies live some 10,000 feet underwater. They got their name because they look like flowers, except they're not plants, but animals. Don't be fooled by their stems and leaves. Those are body parts equipped with nerve endings to detect food around them. Goblin sharks are probably some of the most weird-looking sharks that live at the bottom of the ocean. They can grow up to 12 feet long and have a very unusual snout. Now, take a look at the anglerfish. It has a bioluminescent blob on its head to attract prey and navigate its way around the dark ocean floor. It's a natural flashlight that never needs new batteries. It's only the females that have these flashlights, though. The blobfish is another bizarre animal living down there. It lives in the Atlantic, Pacific, and Indian Oceans, 9,000 feet under the surface. Anyway, even though you asked everyone to keep the news confidential, it somehow leaks to the media and becomes a new trending topic. You get a call from a news agency. They say they want to interview you about this breakthrough that may prove life exists in outer space. The next day, you head down to the news station to talk about your discovery. You have a whole live studio audience watching your every move as you reach out to grab your glass of water. The crew scurries around doing some last-minute checkups before you're live on air. The makeup artist does some final brush-ups. The sound engineer asks you to test your mic once more. Several of the producers are sitting in the front seats. Bright lights are flooding the studio. The countdown begins. 3, 2, 1, and you're introduced. And the host asks you to explain what it was that you heard. You tell them about the Juno space probe orbiting Jupiter. After a couple of questions, the host finally brings up the most dreaded one. Might the mysterious sound be coming from another civilization? Everyone leans in, waiting for you to answer. You freeze, not knowing what to say. Even though the crushing pressure at the bottom of the ocean is 1,000 times stronger than at sea level, life still exists there. Algae, which is considered a delicacy in the ocean world, is off-menu for deep-sea creatures due to a lack of sunlight. Many of these bottom dwellers have to munch on leftovers instead. Those sink down there from the upper layers of the ocean. The freezing temperatures and the intense pressure have altered the cells of these creatures. This has made them more resilient than the average fish. Bacteria were developing their own ways of surviving. Studies show that they feed on certain gases and chemicals, like sulfur and carbon dioxide. Methane and hydrogen are released when tectonic plates move against each other, and some of these bacteria feast upon those gases too. Tardigrades, also known as water bears, are microscopic critters that can live and thrive in extreme conditions. You can find them in volcanoes, frozen glaciers, and even in the empty void of space, which means that some life forms might actually exist on Ganymede. You explain this to your audience. Then you mention that you don't have enough information to determine if it was another civilization or a natural phenomenon that produced the sound. This doesn't mean that the bottom of Ganymede's freezing oceans isn't teeming with its own bizarre and weird creatures. There might be some legendary beasts like the Kraken or Leviathan there, or weird glowing fish with 2 heads, a fish with tentacles and a large fin, giant crabs. The bacteria there might be as varied as our own. The plants, if they exist there, have to be strong enough to survive the sub-zero temperatures. The animals on Jupiter's largest moon could be as big as our blue whales or as tiny as plankton. After the interview, you head back to the lab to examine the records once more. On your way home, you see posters of yourself with captions like, "Are we not alone?" Hey, you've become a celebrity. Many people take pictures of you. You've been booked by other agencies for more interviews. Some science magazines even want to put you on the front cover as the Person of the Year. Every time you come to work, you wait for the sound to appear again, but nothing. You send a signal from the Juno probe, trying to make some sort of contact with whatever produced the sound. Nothing. That night, you pass out on your desk once more. Eureka moment wakes you up in the middle of the night. There might be something you've missed. You run the numbers again and realize that the answer was in front of you this whole time. It wasn't another civilization that produced this sound. The source was electrons. Every planet produces its own sound. It's created when charged particles from the solar wind and the planet's magnetosphere interact with one another. That's what happened on Ganymede. The electrons in its magnetic field, where the probe picked up the signal, were acting stranger than usual, and this amplified some irregular frequencies. You're embarrassed and spend the rest of your night making phone calls, telling your team the news. The agency that interviewed you releases a statement. They explain that other civilizations aren't trying to contact us. You sit back at your desk, waiting for the next big thing to happen. Europa is another of Jupiter's moons that may host life. It's made up of an iron core, a mantle, and a salty ocean, twice the volume of all the oceans on Earth. And just like Ganymede, the ocean lies under a water ice crust. Scientists claim that there might even be active volcanoes there, and some resilient bacteria may live there. With enough water, certain chemicals, and a source of energy, Europa could produce life. But it's unlikely that we'll find anything but tiny microbes.
Without knowing languages, people from different countries won't be able to communicate with one another efficiently. And imagine if some extraterrestrial civilization sent a message to Earth. How would we figure out their intentions? Like, do they want to get to know us better? Or is it a warning about a full-scale intrusion? It must be terribly hard to bridge the gap between us and creatures whose minds, bodies, and habitats are totally different from ours. So, to practice decoding potential extraterrestrial messages, an artist-led group created a mock message from stars. It was the most alien missive the world had ever seen. Even though it was written for humans by humans, it was as non-human as possible. The message was sent from Mars to Earth, and 3 observatories detected the transmission 16 minutes later. Unfortunately, so far, no one has deciphered the message, but many have been trying to do it. There are only 3 people in the world who know what the message means. One of them is the project's founder, Daniela De Paulus. She and 2 other co-authors created the message after consulting with scientists, poets, programmers, and philosophers from all over the world. The main challenge for them was to get rid of anthropocentricity to make the message as realistically alien as possible. So the team immediately ruled out any kind of language-based communication. Even though now they refuse to confirm or deny that the message contains text, the creators were also considering using mathematics. Yes, the fundamental concepts of this science are universal, but different cultures may represent math differently. De Paulus and her team struggled to compose the message for years, experiencing massive writer's block. But eventually, in 2019, the idea was formed. 3 years later, in 2022, a major breakthrough occurred when the team drew inspiration from a short story called A Sing in Space. And a month before the transmission, an astronomer joined the team, adding a mathematical touch to the message to make it more universal. Since the first announcement, the project has attracted loads of puzzle lovers. They started to exchange ideas, hoping to solve the mystery. Some of them were among the first people to extract the raw message from the ExoMars orbiter's broadcast. It was a 40-gigabyte string of numbers interwoven with the alien message. If it had been real, it would have arrived unannounced, of course. But in this case, the signal came at a precisely scheduled time. Now imagine peeling layers off an onion. That's what filtering the data segment looked like. But after a week's effort, the enthusiasts received an image of 5 speckled clusters against a blank background. After that, the speculation on the meaning of this picture started. Could the message be hinting at the alien's appearance? Was it Morse code? Maybe it hid some genetic secrets? One user even enlisted ChatGPT to help decipher the message. There was also a theory that the image was a star map with the location of the alien civilization. Another suggested that the dots resembling constellations could be molecules. Probably, they were part of the biosignature of the foreign world. But decryption is the process of making sense of some message for which only the intended recipient has a key. That's why this kind of code breaking is much more difficult than decoding, because you need to guess the missing key. Another tricky part is where to start. Every attempt feels like a stab in the dark. You might believe that you have started to see patterns, but you need to stop and think whether it's true or you're just projecting. The community is still trying to decode the message. At the moment, there are more than 30 ideas for how to do it. Only after that can people try to understand its full meaning. How about you? Would you like to try and take part in the process? Maybe you've got some idea? Then share them with us. Even though it may seem that science has reached the level where there are no more mysteries left, it's not exactly true. And no modern physicist would dare to assume that our knowledge of the universe is near completion. What are scientists still wondering about? Let's figure it out. For one thing, dark energy keeps puzzling researchers even today, because the universe doesn't seem to add up. Even though gravity is pulling space-time, the very fabric of the cosmos, inward, the universe keeps expanding outward, and this process is speeding up. That's how the concept of dark matter was born. It's believed to be some invisible agent that counteracts gravity by pushing space-time apart. It goes like this. The universe expands, and more space appears out there, and with it, more dark energy. According to astronomers, this invisible energy must make up more than 70% of the universe. But no one knows how or where to look for it. Then there's dark matter. You see, around 84% of matter in the universe doesn't emit or absorb light. Scientists call this stuff, which can neither be seen directly nor detected by indirect means, dark matter. Its existence is inferred from the effects it has on visible matter, radiation, and the very structure of the universe. There are a few special detectors on the lookout for weakly interacting massive particles, of which dark matter might be composed. But so far, nothing has been found. One of the most recent studies claims that dark matter might produce long, fine-grained streams radiating out from Earth like hairs and streaming throughout the universe. But it hasn't been proven yet. Then, there's the question of antimatter. It's the oppositely charged and oppositely spinning twin of good old matter. The intrigue here is why there is more matter than antimatter in our universe. It would be logical to assume that the universe would want to treat matter and antimatter equally. Thus, at the moment of the Big Bang, equal amounts of matter and antimatter should have been produced, right? Not really. If it had happened, there would have been a moment of total annihilation. Protons would have canceled antiprotons, electrons, anti-electrons, and so on. It would leave behind a lifeless, matterless expanse of space. Luckily, for some mysterious reason, when the universe was created, there was some excess matter. It didn't get annihilated, and that's how everything started. But there's still no accepted explanation for this. Then, we've got particle physics questions. They account for many unsolved problems. Sonoluminescence is one of them. Let me explain. Let's say you take some water and hit it with sound waves. It forms bubbles, low-pressure regions surrounded by high pressure. Once the outer pressure pushes on the lower pressure air, the bubbles collapse. But while collapsing, they emit light, even though the flashes don't last for more than a trillionth of a second. What bothers scientists is that it's unclear what the source of this light is. There are a few theories, of course. Some experts think tiny nuclear fusion reactions might be involved in the process. Others believe some kind of electrical discharge comes into play here. There's also the idea of compression heating of the gases inside the bubbles. None of these theories have been accepted yet. This might sound surprising, but we haven't figured out what exactly gravity is either. Other forces are mediated by particles, but not gravity. Some physical theories claim that it might be carried by a hypothetical massless particle called a graviton, but no one has seen these gravitons yet. We don't even know what kind of detector can be built to spot them. Even if gravitons come into contact with matter, and we aren't sure about it, they do it extremely rarely. There's also a theory that gravitons are closed loops of energy, but again, it's just a theory so far. There are tons of other unanswered questions bothering our minds. What happens inside a black hole? Is string theory correct? What is the fate of our universe? Do we live in a false vacuum? Hopefully one day we'll find the answers to all these mysteries.